for today. So, yes. I would go after this. Or you're going at 12. Then you can just exit when you need to. So in this example, ladies and gentlemen, we have 2x squared minus 16x divided by x squared minus 9x plus 8 times 5x minus 5 divided by 2x. OK? Now, I'm just going to show you there's a couple steps that we need to know ahead of time to make sure that we can do this one efficiently. Because one thing you guys notice, what's different from this problem compared to last problem was this one, now we have addition and subtraction, right? We have terms that are separated by addition and subtraction. Well, see, the thing is, we don't have to multiply. Again, the purpose of this is, yeah, we're multiplying. But before we actually multiply, what we're going to want to do is simplify our expressions. So the tip with this one is, unlike the last one we just multiplied across, right? It made sense. Multiplied, and then we simplified. When we have ones with expressions that are separated by addition or subtraction, our first step is going to be to simplify. So how do we simplify these terms? Well, to do that, it rhymes with tractoring. Factoring. So what we want to do is think about factoring. Now remember, factoring is rewriting an expression as a product. So the way that I think about this in my head, even though we've already taken a test on this and we should already have done our homework on this, the way that I think about factoring in my head is I think about factoring as the area of a box. And to factor it, we want to find the length and the width. OK? So think about it.
Why wouldn't you have the x in the box?
I'm taking, oh, there is the x in the box. Thank you. I missed that. OK. So think about it, guys. If this was the area of my box, would I say that the length could be 7? Would I want to use that 7 as my length? No, because then you're going to be multiplying by fractions, right? So what do you think would be a good length to use as the width or the length of my box?
4.
4.
2.
2. Well, you could use 4, but the problem is 4 times what gives you 2? You have to use 1/2, right? So then you're using fractions. Nobody wants to use fractions. So the largest number that divides into 2 and 16 is 2. And then what about variables? Should I multiply by a variable? X. So now let's go and see. So if we say the length is 2x, what should the width be? 2x times what gives me 2x squared? X. 2x times what gives me negative 16?
8x.
Negative 8. So do you guys agree with me that the expression 2x times x minus 8 is the same thing as 2x minus 16x? So that's what factoring is. Oh, it's funny. So that's exactly what factoring is. Factoring is rewriting an expression as a product. That's what factoring is. So I factor the first expression, which is 2x times x minus 8. Now, can we factor 5x minus 5? What do you guys think that would be? What length should I use? 5. Well, we could always use 1. So we want to try to see if we can. Good. Yep. Do you guys agree with me? OK. OK. I'm going to erase this then, OK? This. OK. Well, can we factor anything with the 2x? No, we can't. We're not going to rewrite that as a product. So now the next important thing that we're going to practice is factoring the trinomial. And this is where I know a lot of students, even though this one gets me upset because we spent, I gave you guys that whole packet. I gave you 20 of these problems to do, right? Huh? Yeah, we're not even done. It's like a multi-step. I'm going through this problem very, very slowly.
You should just let us do like 6 of these problems and give us days.
Well, let's see if we can do one problem first. So the main important thing, guys, when you're factoring a trinomial, which you guys should be familiar with. So here's my trinomial, correct? When we're factoring all trinomials, it's all the same stuff. A times C over B. Multiply, add. In your notes, you should have multiple of these because I've done this multiple times in this class. Anytime you have a trinomial that you're trying to factor, you can always set it up with A times C and B. Now what's nice about this fact is A times C, A in this case is 1. So my C is just 8. So I write 8. And then my B is Negative 9. So now I need to determine what two numbers multiply to give me positive 8 and add to give me negative 9.
Negative 8 and negative 1.
Negative 8 and negative 1.
Wait, why wouldn't it be, why wouldn't the variables
Why aren't the variables what?
why don't they go in there?
Because it's only the coefficient. A is coefficient, B is a coefficient, and then C is the constant. So it's only 8 times C and B. Huh? Well, this is factoring that. Now I'm factoring this one. So we got to factor every single one. Okay? But here, see, a trinomial, we can't use a box like this. Okay? Because here's the problem. If you guys want to use the box, let's use the box method. X squared minus 9x plus 8. Here's the problem. Is there any number you can write for your length that you can multiply by all three of these? No, they don't share anything in common. So we can't use the box like we did over here. So when you have trinomials, that's why we use this. However, I will let you guys know we can use a box. But the box has to be drawn a little bit differently. The way that we draw the box is with 4 terms. So instead of drawing it like this and determining what the length and the width is, what we do now is we take, all right, let's write the first number and then the last number.
Is this just another way to do it?
Yeah, I mean, I'm going to explain a shorter method once I'm done with this. And we're going to do more of these anyways. So now I take negative 8x and I take negative 1x. OK, so what I want you guys to see here, I want you guys to visually see. Do you guys agree with me that x squared plus, minus negative x and negative 8x is the same thing as negative 9x? You guys agree with that? So do you guys agree that this, the area here, is the same thing as this? Because these two combined give you negative 9x. Does everybody see that?
Yeah.
So now, just like we did here, we got to find the length of the width of this box. So to do that, what we do is we start with the upper left corner. What should the length be for x squared? X and x, right? Now, x times what gives you negative x? Negative 1. X times what gives you negative 8? Negative 8. So would you guys agree with me that x minus 8 times x minus 1, this times this, length times width, gives you the area? OK, well, guess what, guys? This is now the factored form of this. X minus 8 divided by x minus 1.
X minus 1 cancels out.
Yep. Well, I'm going to go to those in just a second. I just want to make sure everybody understands how I factored this. What I did was I broke up the 9 into negative 8 and negative 1. I broke it up into 2 different boxes. How did I get negative 8 and negative 1? I did this diamond part. Right? That's where we get that. OK? Now, what's helpful with the trinomials is what's beneficial with the trinomials. Guys? Huh? So, I know. OK, so let me try to explain it without talking over some people. Guys, yeah, you don't need the box when you're doing trinomials when a is equal to 1. OK? When a is not equal to 1, these are not, see what's nice and what's important about this, here's the kind of shortcut. When a is equal to 1, these values, you guys can see, are right there, right? So it's easy. You don't even need to do the box. It's good. But if a was not equal to 1, if this was like this, 2, then these values would not be that. You would have to use the box. OK? You can use the box for both problems. But what's nice about this one is because you have the shortcut where a is equal to 1, you can use the shortcut and you can simply just take these 2 values and put them right there. So now let's go back to our original, let's go back to one of the things we talked about. We know that 3 divided by 3 is equal to 1. X divided by x is equal to 1. So x plus 3 divided by x plus 3 is equal to, Deja, this is not going to be earning points here. X plus 3 divided by x plus 3 is equal to 1. Kelsey, that's the same thing for you as well.
Mr. McLogan, I'm earning points.
That earns you as a warning. I'll just let you guys know. Yes, OK. Keep on going. Keep working. So now, in this case, now we guys can see that x minus 8 divided by x minus 8 divides to 1. X minus 1 divided by x minus 1 divides to 1. 2x divided by 2x goes to 1. So we're just left with the final answer.
Where did those threes on the corner right pocket?
Nowhere. I was just explaining something. 3 divided by 3 is equal to 1. X divided by x is equal to 1. So x plus 3 divided by x plus 3 is equal to 1. You need to know that relationship. So therefore, you can see that those divide all to 1. We are just left with 5.